So this video is going to springboard off the last example where we had several different radicals that were being multiplied, and we get a lot of cancellation if we combine the radicals that we have all under one giant radical. So here we're looking at two different fourth roots, and I have 5 x's here, I have 16, I have 27, I have x's in the denominator over here, I have y's here, and I have y's here, and I have z's here. So ideally, if I were able to combine these all under one radical, I'm going to get a lot of cancellation of x's and y's. I'm not going to be able to cancel any z's because I don't have any in the numerator. So if we just employ the product and quotient rules for radicals, we'll be able to do the following. So notice first we have a fourth root on both of these radicals. Therefore, we can combine them into one radical. So how do we do that? One giant radical, fourth root, so it'd be 16 x to the fifth times 27. I'm not going to multiply the 16 and 27, and I'll explain why in a minute, times y to the fifth. Okay, that's the top of that. Y to the sixth times x to the fifth times z to the fourth. Okay, so now I have everything under one giant radical, and that's exactly what we want. Now I can cancel stuff. So notice first that I have 5 x's in the top, I have 5 x's in the denominator as well. So these guys end up canceling out. I have 5 y's in the top and I have 6 in the denominator. So if I were to cancel out as many y's as I possibly could, I'd end up with only 1 y left over in the denominator. So instead of skipping steps, I'll write that out. I'll cancel those x's that I mentioned before, keep the 16, we'll keep the 27, and I have y to the fifth over y to the sixth times z to the fourth. Okay, so as I mentioned before, we have 5 y's on top, we have 6 on the bottom. So because of that, 5 of the y's are going to cancel out of both of these guys. So I'm left with fourth root of 16 times 27 all over y, just one y. And then we have a z to the fourth here as well because we haven't done anything with it. Okay? As you can see, I keep correcting my radicals because I want to extend this so that it encompasses everything. So it doesn't look like I'm just writing the fourth root of the numerator. So you might have to keep that in check as you write things down quickly. So 16, if I were to break that down, was going to give me 4 times 4, or 2 times 2, times 2 times 2. So we're thinking factor trees for these guys. But first we'd want to isolate the radicals. So use the product and quotient rule again. You get, well, I'll use both at the same time. You end up with fourth root of 16 times the fourth root of 27 over the fourth root of y times the fourth root of z to the fourth. Notice that we have z to the fourth root, okay? These are going to cancel out. So this will leave us with just an absolute value of z because we have an even root that we're talking about in an even power. So you have to write absolute value bars in that case because we don't know if z is going to be positive or negative. Okay? So let's also break down, we'll keep that in mind for now. And then 16, how does that break down? Factor tree. So that gives me 2 times 8, 8 is 2 times 4, and 4 is 2 times 2. So I have a cluster of 4 2's, and that's great because I have a fourth root. Let's look at 27. 27 breaks down into 3 times 9, and 9 breaks down into 3 times 3. So I only have 3 of those. So that way I can't cancel the fourth root. I don't have enough 3's. So I'm going to just leave that 27 as is. I'm going to rewrite the 16 as 2 to the fourth. And as before, I'm going to write this guy, the fourth root of z to the fourth, as absolute value of z. So I'm just handling one step at a time for the most part, but keeping things straight in my head. So I have fourth root of 2 to the fourth times fourth root of 27, because we couldn't break that down into groups of 4 3's. I have fourth root of y times, well, let's just handle the absolute value of z right now. Okay, so I have 4th root of y times the absolute value of z in the denominator so far. Okay, continuing on, this gives us what? So we have 2 to the 4th rooted. That's just 2, because the 4th cancels the 4th root. And since 2 is positive, we don't need to put absolute value bars on 2, because absolute value of 2 is just 2. So we have 2 times square root of 27, or 4th root of 27, all over the 4th root of y times absolute value of z. Okay? So how do we simplify this further? Notice that I have a 4th root on top and I have a 4th root on bottom, and everything in sight is being multiplied. So how do I combine that? Well, rewriting this and using basic fraction rules, this is 2 over absolute value of z times 4th root of 27 over the 4th root of y. Okay? And now I'm going to rewrite this as one giant radical, just using the quotient rule for radicals. Can't really do much with this 2 over absolute value of z, so that's just going to come along for the ride. So I have 2 over absolute values of z times the 4th root of 27 over y. And with that, we are stuck. This is as far as we're going to be able to go. Can't cancel anything else, and our example is done. And if you haven't done so already and you found this video helpful, please smash that like button, and I will see you in the next one.